All right. So yesterday we worked with the sum and difference identities, and hopefully you've learned that they're really not that bad as long as you don't overthink it and just follow through with your algebra. Which by this point, given some of the identities I've given you prior to yesterday's, you should have been a little more well versed. So today we're going to talk about the double angle identities and the power reducing trig identities. You guys actually figured out the double angle identities yesterday. You just didn't know that's what you were doing. Um, well, maybe some of you did. Some people that I spoke to didn't seem like they made that connection or knew that that was a thing. So when I asked you to find sine of x plus x, well, according to our um, double angle identity, we know that'll give us a sine of x cosine of x plus a cosine x sine of x, which comes out to 2 sine of x cosine x because you have two like terms here. So 1 plus the other gets me that 2 there. However, if I simplify this part inside the parentheses, well, I get that's really a sine of a 2x. So that's one of your double angle identities, right? And if I repeat the process with cosine, cosine is actually a little bit interesting because of what you end up with. All right, cosine of x times a cosine of x minus a sine of x times a sine of x should get me a cosine squared of x minus a sine squared of x, which again, if I add the x plus the x inside of the original part right here that I'm about to underline, well, that means that's a cosine of 2x. However, since we have cosine squared and since we have sine squared, I could access some of my Pythagorean identities and continue to rewrite this. So the cosine of 2x has two more additional forms that you should know exist. And if you forget, you can just do the substitution real quick. So if I replace the cosine squared with 1 minus sine squared, then I can say that 1 minus 2 sine squared of x should also be equivalent to cosine of 2x. And if I replace the sine squared with 1 minus cosine squared, then I would have 2 cosine squared of x minus 1 is also equivalent to cosine of 2x. And you never know which one of these forms would be beneficial to you. So it's important that you think about, which one makes more sense in the context of the problem. And we'll get to that a little bit later when we talk about using these identities to solve trig equations. But for now, we're just going to focus on the fact that they exist. All right, and the last one is tangent of x plus x. Right, and if you just go back to your work, you should have gotten 2 tangent of x. You have to add the 2 tangent of x's that you get up top over 1 minus. You have a tangent of x times a tangent of x, so you can call that tangent squared of x, which again, that's the double angle identity for tangent. You guys did that all on your own yesterday, so there you go. That's why I had you do that. So let's talk about the power reducing identities. So for these power reducing identities, they're actually a manipulation of what we have right here with the cosine double angle identity. So let me show you what I mean. Okay. So based off what we did for the double angle identity in the orange, we know that 1 minus 2 sine squared of x should be equal to a cosine of 2x. That means that negative 2 sine squared, oops. Sorry, there's a pop-up that showed up. I don't know where it came from. Sine squared of x is equal to cosine of 2x minus 1. Divide all that by a negative 2. So sine squared of x should be equivalent to 1 minus cosine of 2x divided by 2. So that's what we call a power reducing identity, because I can go from a squared to not a squared if I do the substitution. And in a similar fashion, if I take the purple identity and solve for the cosine squared, right, we can get a cosine version of this. And just to kind of keep the structure similar, I'm going to choose to write this as cosine squared of x should be the same as 1 plus cosine of 2x divided by 2. So that way both purple and orange, it's 1 followed by a cosine of 2x. All of that gets divided by 2. The only difference is if it's a plus or a minus, which you can find a way to help you remember that. So that's up to you. So those are the new identities that I'm going to show you today. There's a couple more, but I'm going to hold off on that for tomorrow because this is already kind of long. So I'm going to show you how this works now. All right. So I've written all the double angle and power reducing trig identities up there so we can go back and reference them. All right. Hopefully you guys have written them somewhere, or the trig identity sheet that you found on the internet contains them. So let's use them. In this instance, we're going to take sine of 3x and rewrite it in terms of powers of sine of x and constants. So note, I can only use sines of x's, raised to powers, maybe not, and I can only multiply or add or subtract numbers to those. All right. So the first thing I notice is I have sine of 3x. Well, 1 plus 2 is 3, so I could rewrite that right now as, whoa. I could rewrite that as, whoa. Rewrite it? No. Oh, no. We'll pick this up next video. I can't write